Greetings, geometry students. Starting with this week, we're going to be getting into some topics that hopefully you have seen a little bit of through your travels in junior high. So we'll be refreshing our memories on some old formulas and some old equations and things like that. And we're going to begin that discussion with the formula for midpoint. Please copy down your midpoint formula title as well as your objectives. Our stated objective for today is the student will acquire basic vocabulary, understanding, and workings of the midpoint formula. In order to perfect this skill, the student will demonstrate the ability to utilize the midpoint formula while completing a class activity. We're going to be out in the hallway a good bit this week as we work through these formulas, making sure we understand how the formulas and equations work when we are dealing with graphs. And your essential question for the day is, can I find the midpoint of a line in a graph? As always, press pause anytime you need more time to copy something down, and then hit play whenever you're ready to move forward. Okay, so let's take a look. Now, basics of graphing. Remember that any location in a two-dimensional coordinate system, okay, and actually the name for that coordinate system, if you are unfamiliar with it, it is called the Cartesian coordinate plane. Any location in a two-dimensional coordinate system, which is called the Cartesian coordinate plane, has a coordinate. Any location has a coordinate, which is this guy that we've seen so many times, x comma y. And that x comma y describes that precise location. So anywhere you go in the Cartesian coordinate plane, if you just randomly point your pencil at the paper, there is a coordinate, x comma y, that describes precisely where that location is sitting at. And no other location in the graph will have that same coordinate, x comma y. Okay, so I'm sure you're all familiar with that, okay, but bear with me while we review. Got to make sure everybody understands. Okay, here is a basic Cartesian coordinate plane. It exists of two axes, one running left to right, the other one running up and down. They intersect at a location that is called the origin. That is the coordinate 0, 0. Now, all the other points are going to have values that relate to how they line up with these axes. Okay, the horizontal axis that runs left to right is called the x-axis. As you move to the right from the origin, those are the positive x values, and as you move to the left from the origin, those are the negative x values. Hopefully you remember that from long discussions through elementary and into junior high of the number line. That is your basic number line, the negatives to the left and the positives to the right. The vertical axis is the y-axis. As you move up from the origin, these are where the positive y values exist. And as you move down from the origin, these are where the negative y values exist. Now, as I said, if you place the tip of your pencil anywhere within the graph, you get a point. That point has a particular coordinate, x comma y, depending upon how it lines up with the x-axis and with the y-axis. And wherever those alignments occur with the axes, you have your coordinate, x comma y. In this case, it would be a positive x value, looks like 3, positive 3, and a positive y value, looks like positive 5, because it did hit the positive x-axis and the negative x-axis. I'm sorry, the positive x-axis and the positive y-axis. Said that incorrectly. Okay, now, obviously, more than one point can exist in the graph at a time. So we have, if we have 2 points in the graph, which we refer to as point 1 and point 2, those little small numbers floating downwards are called subscripts, and it indicates that we have more than one point, and we're kind of naming them, point 1, point 2. Point 1 is said to exist at x1, y1, wherever that may be in the graph. Point 2 is being said to exist in the graph at x2, y2. Okay, now the 1s and 2s and all that kind of stuff don't mean anything about the coordinate. It's just that we're using all these subscripts to keep the information straight. Point 1 is at x1, y1, all the 1s go together, and point 2 it lives at x2, y2, all the 2s go together. So for any 2 points, point 1 and point 2, there exists a midpoint between them. And that midpoint lives precisely at, and we have a formula. The formula itself is built inside of parentheses, and we'll explain that here in just a moment. Okay, so do copy down the parentheses as well as the comma that lives in the middle of the formula. It's all part of the formula, so don't leave those guys out. And the information that goes on either side of the parentheses is this. Okay, we have a fraction in each case. On the left fraction, we have x1 and x2 being added together in the numerator, and then they are divided by 2. And then on the right side, y1 and y2 being added together and being divided by 2. Now, with me, the key to understanding formulas is to be able to explain them in plain English. Okay, this is a difficult formula to remember, but not a difficult formula to understand if you can verbalize it. Okay, so the verbal of this formula would be you have the average of the x values, comma, the average of the y values. Obviously, it's an average, 2 numbers adding up and being divided by 2 in each case. Midpoint is found by the average of the x's, comma, the average of the y's. If you can remember it that way, it's not that difficult to keep it in your memory. Okay? There's our midpoint formula. Now let's look at this graphically. I think you probably understand, but I'll show it to you anyway. Okay, there is our Cartesian coordinate system. The x-axis is horizontal, the y-axis is vertical. X's are positive to the right, negative to the left. Y's are positive going up and negative going down. As we said, any point that exists in the Cartesian plane has a location, a coordinate that describes its position as it lines up with the x-axis and with the y-axis. So here we have a possible point 1. It lives at x1, y1. And we could have a second point that exists somewhere in the Cartesian coordinate plane. It will, of course, align with the axes. And in this particular case, it happens to hit the negative x and the negative y. But again, that's just its coordinates. So we have a second point, point 2, that lives at x2, y2. Now, if these 2 points were to be joined together with a line segment, that line segment will definitely have a point that is the midpoint between point 1 and point 2. So it will be equidistant from the green point to each of the red points. The particular location of this point is given by the formula, the average of the x's, comma, the average of the y's. And the result of that formula will tell you exactly where that coordinate lives at. Okay, so since the midpoint, as its name suggests, is a point itself, we expect our answer to be an ordered pair. That is how come the formula itself has parentheses built into it, as well as a comma separating it. It is giving you the information that your result of this formula should be an ordered pair. Parentheses x, comma, y, close parentheses. Okay, so let's move on. Take a look at a couple of examples here. There are some simplistic type problems that you have probably seen similar ones in junior high. They might have looked like this one. Find the midpoint between points 2, 3 and 4, 1. Now, if you've dealt with this formula before, you know that this is not a real challenging calculation. However, I do have a couple of strategies that I absolutely want you to use in my classroom. And those strategies would be this. First off, in order to find a midpoint, you need to know the coordinates of the end points. In this case, we do know the coordinates of the end points. They are 2, 3, and 4, 1. I want you to get in the habit of labeling these coordinates. Okay, we said the midpoint will be the result of the equation using point 1, which lives at x1, y1, and point 2, which lives at x2, y2. I actually want you to get in the habit of every time you work a formula using the midpoint, work a problem using the midpoint formula, I want you to actually write this down. Okay, find one of the points and actually label it x1, y1, and find the other one and label it x2, y2. It does not matter which point is point 1 and which point is point 2. It will not affect the answer. I also want you to get in the habit of any time you have to use a formula in my class, I want you to actually write the formula down. Okay, so we're actually going to write it down. We're going to put our parentheses with our comma in the middle, x1 plus x2 over 2, and y1 plus y2 over 2. And we're going to do that every single time we have to use a formula in our class. Yes, I know that sounds a little tedious and it's boring and it seems stupid that you have to write it over and over again, but let's face it, we are not real good at doing calculations in our heads, so we do not need to be trying to plug numbers into a formula in our heads before we actually write that down. So we're going to get the formula written down and we're going to get our problem written down before we try to start installing anything into the formula. Now, once you have your points labeled and your formula written down, now is the time to start installing information into the formula. Okay. Now, the denominator here is kind of non-negotiable. It came with the formula. There's nothing we can do about it. We will simply do the math when the time comes. But we have to make sure that we get the numerator right. Now, the numerator shouldn't be any problem at all because we have all of the information labeled and the formula written down right in front of us. So all we have to do is simply, it's kind of like a connect the dot puzzle, plug the information in where it goes. On the left side numerator, the formula says x1. So we look at our points and we find what we labeled x1, and that's the 2. So we're going to put the 2 in the left numerator. Then the formula has a plus sign, and then the formula asks for x2. So we get that, which is labeled 4. Okay, so we have on the left numerator 2 plus 4. Very simple. On the right side, the formula asks for y1, so we go to our points where we labeled them, and we see that y1 is 3. The formula has a plus built into it, so we will put that down, and then the formula asks for y2. We go to where we have it labeled, and that is a 1. So we're going to put in a 3 plus 1 on the right side numerator. Now what we want to do is we want to simplify the binomials in the numerators before trying to divide by 2. So on the left side of the problem, our numerator is a 2 plus 4, which is 6. And on the right side numerator, we have a 3 plus 1, which is a 4. Once you have simplified the little binomial that was in the numerator, now you can divide by your denominator, and that should lead us to our midpoint. On the left side, we have 6 divided by 2, which is 3, and on the right side, we have 4 divided by 2, which is 2. The midpoint between the 2 points that were given lives at 3, 2. So that's not so bad. Let's look at another one. There's a lot of different ways that they can word these questions because there's a lot of different vocabulary they could use. We could use midpoint, bisected, all kinds of things like that. So what is the coordinate of the midpoint of line segment AB if A is at 0, 6 and B is at -3, -2? As we said, there's a lot of different ways they can word these. It's up to you to read the problem and determine that they are asking for midpoint. They want to know where is the center of this line segment. So same strategy as before. Write down your coordinates. Label them, x1, y1, x2, y2. Write down your formula. x1 plus x2 over 2, comma, y1 plus y2 over 2, and the whole formula is in parentheses. Will your answer be incorrect if you do not put parentheses around them? Yes, it will. Okay, it is a point. It is a coordinate. It needs the parentheses around it in order to be that. So if you leave the parentheses off or leave the comma out of the middle, you have absolutely changed the answer, and that will cause you to at least lose some partial credit. Anyway, plugging into the formula. Okay, so once again, here we go. x1 is 0, x2 is negative 3, so I plug them in. y1 is 6, y2 is negative 2, and I do believe I have an error right there in my formula. Sure do. Let me change that. Should be a plus. And to be perfectly honest, this should have been a plus negative right there. Not sure why that was that way. Anyway, looking at the next step, parentheses, and my file's got the same problem again. Okay, hopefully I'm picking up the same point that I left off. I just pressed the pause button and corrected this file, so if I'm not on the same screen that I left off at, I apologize. Anyway, there now the numerators look like they're supposed to look: 0 plus negative 3 and 6 plus negative 2. Okay, moving on into the next step, we're going to simplify the numerators. 0 plus negative 3 is negative 3. On the right side, 6 plus negative 2 is 4. After the numerators are simplified, then we can combine with the denominator. Okay. On the left side, 2 is not going to go evenly into negative 3, and that's okay. That is part of the deal. Sometimes when we divide by 2, if we don't have an even number, we're going to end up with a fraction, but we definitely do want the fraction. So 2 goes into 3 1 1/2 of a time, and since it was a negative divided by a positive, the answer is negative. And on the right side, 4 divided by 2 is 2. Okay, so there is our midpoint. Can we have midpoints at fractions of values? Absolutely, we can. Okay, so that's probably the way you've been using midpoint formula up until this point. In high school geometry, you're going to see that there is one step further that this can be taken. So let's take a look at a new type of problem that you're going to face. And it will be something more along the lines of this. If B is the midpoint of line segment AC, then where would point C be located at? So instead of being given the end points and looking for the midpoint, perhaps we are given one of the end points and a midpoint, and then are asked to determine where the other midpoint would be located. Okay, so there is a line segment AC which is not shown in the problem. It is going from point A in the first quadrant down past through point B and even further down into the left of point C. Now the goal here is not to draw a bigger graph and try to figure out where point C would be. We want to use the midpoint idea in order to help us figure out where point C would be at. And here's how you do it. Now, if B is the midpoint between point A and point C, then the distance traveled from point A to point B will have to happen again to get from point B to wherever point C is at. That is the basic idea of what a midpoint guarantees us. So we're going to use that information to help us pinpoint where point C is at. Okay, so here's what we're going to do. We've got point A, which lives at 1, 5, and we have point B, which lives at -2, -4. What we're going to do is we're going to figure out how far or how much did the x value change to get from point A to point B, and then we're going to find out how much did the y value change to get from point A to point B. Okay, so how much did the value change? If we went from A, which was at 1 on the x-axis, to point B, which is at -2 on the x-axis. What is the change there on the x-axis? That is a change of -3 units. Okay, now let's look at the same information on the y values. Point A was way up at 5 on the y-axis. Point B was all the way down to -4 on the y-axis. How much of a change is that, getting from point A to point B? That is a change of -9 units. Okay, now why is that important? Because we are going to apply the same amount of change to get from point B now to point C. Moving from point A to point B, the x value changed -3 units. So we are going to force it to change -3 units again. So if point B is at -2 on the x-axis, and then we move another -3 units away from point B, where would that put point C at? Well, -2, -3 more is -5. That is where point C is going to line up with the x-axis. Same thing, we're going to move from point B to point C. Okay, well, how did point A change to point B on the y-axis? It came down 9 units. So moving from point B to point C, we're going to have to come down another 9 units. So how far is it? If you go from -4 down 9 more, that would be -13. Point C must live at -5, -13 if B is the midpoint on line segment AB. This is a little bit more the speed of the type of questions that you'll see on midpoint questions in high school. Okay, that is it. Please do your summary, jot down any questions that you may have, and always keep in mind your essential question: can I find the midpoint of a line in a graph? I appreciate you taking time to get your notes taken care of, and I will see you in class.